Hello students, my name is Dr. Abhijit Shah. I'm taking this BTech chemistry course. This electrochemistry is a part of your BTech syllabus. It is a part of module 2. So in electrochemistry, we have to know what is Nernst equation, application of the Nernst equation, and we have to solve some problems based on the Nernst equation. So please listen this lecture. From this lecture, in this lecture, I will discuss electrochemistry. So first one, when we have to discuss electrochemistry, first thing we have to know what is oxidation and what is reduction. What is oxidizing agent and what is reducing agent? Because in electrochemistry is a nothing but oxidation reduction reaction. Oxidation means the loss of electron, increasing oxidation number or increasing number of oxygen, right? Or decreasing the number of hydrogen. And reduction means gaining of electron, decreasing in oxidation number, decreasing in number of oxygen, and increasing in number of hydrogen. So the agent, so what is next is the oxidizing agent and reducing agent. So the agent which is able to oxidize another substance, able to accept the electron, able to take the hydrogen, or able to transfer oxygen, that is called oxidizing agent. Reducing agent means the agent which is an electron donor. Any negative charge material or having lone pair, okay, or having free electron in like in metal, they are the reducing agent. Okay. So this is the first thing we have to know. Next thing, someone experiment of this is the experiment. So what does copper become blue in color when dipped into silver nitrate solution? If you dip a copper rod or copper wire in a silver nitrate solution, after some time you will see it becoming blue color. So what is the reason of the blue color? So this is actually example of oxidation reduction reaction. So in this reaction, copper is a rod metal and silver nitrate solution, so silver plus is present. Now copper is releasing electron, that electron is taken by silver, and copper become copper 2 plus and silver becomes silver 0. So when copper 2 plus in solution, we know it will show blue color, right? So in this reaction, you can see initially this copper rod. Now next we have seen deposition of metallic silver around the copper rod. Because of that, it becoming this type of white color. So this is the example of an oxidation reduction reaction where copper is giving electron and silver is accepting electron. So which one is oxidizing agent? Here oxidizing agent is silver plus and reducing agent is copper. Next question, what will happen when metal rod of magnesium or zinc or aluminum dipped into a solution containing copper sulfate? So what will happen? So if we dip, right, if we dip a metal rod of magnesium or zinc or aluminum into copper sulfate, so what will happen? We can think the similar reaction. So copper sulfate, previously we had a silver nitrate solution. Now we have copper sulfate solution. So copper sulfate solution means copper 2 plus. Now if we take magnesium or zinc or aluminum, so they will give electron. They will supply electron to copper 2 plus and reducing copper 2 plus to copper. So we'll get deposition of the copper on the metal surface. Okay, so if we dip magnesium into copper sulfate, copper will deposit on magnesium metal surface. If we dip zinc into copper sulfate, copper will deposit on zinc metal surface. And if we dip aluminum into copper sulfate solution, then copper will deposit on aluminum metal surface. So this is also an example of oxidation reduction reaction in solution. Next thing is electrode. In electrochemistry, most important thing is electrode. So what is electrode? Electrode is any substance that conduct electricity by producing freely moving ions when dissolved in a solvent. So, sorry, my mistake. So, what is electrolyte? In electrochemistry, two important things. One is electrode, another one is electrolyte. So, without electrolyte, we cannot perform electrochemistry experiments. So, we need one electrolyte. So, electrolyte is a substance that conducts electricity by producing freely moving ions when dissolved in a solvent, usually water, or in a molten state. Example, sodium chloride. Now, electrolytes are two types. One is strong, another one is weak. Strong electrolyte means the electrolytes which dissociate completely and exist as an ion in solution. That is called strong electrolyte. Ionic compounds are typical example of strong electrolyte. For example, sodium chloride, potassium chloride, HCl, strong electrolyte. Strong acid, strong base, example, sodium hydroxide and their salt are strong electrolyte. They are good conductor because they dissociate well and produce many ions in solution. They conduct electricity when molten or in aqueous solution. Example, hydrochloric acid, sodium chloride. Next is what is weak electrolyte. Weak electrolyte is only partial dissociate in solution and produces relatively few ions. Exists in water as a mixture of individual ions and molecules. So weak electrolyte or weak acid and weak bases are the example of weak electrolyte. They do not conduct electricity so well because few or less number of ions they produce in solution. Examples, ammonia is an example of weak electrolyte, acetic acid an example of weak electrolyte. So next important part is electrochemical cell. So when we know what is electrode, and electrode means, okay, we discuss electrolyte. What is electrode? Electrode means in electrochemical cell we have two solid surface. In those surface, electrochemical oxidation reduction reaction occurs. Those are called electrode. Now electrode can be two types. Sometimes it's called cathode electrode, sometimes it's called anode electrode. Cathode electrode means where reductions occurring, and anode electrode means where oxidation is occurring. Now, with electrolyte and electrode, we can make an electrochemical cell. So, what is electrochemical cell? Electrochemical cell is the device which converts electricity into chemical energy, or vice versa, or chemical energy to electricity. This is called electrochemical cell. Based on the activity taking place in electrochemical cell, the devices are classified into two major categories. One is called electrolytic cell, another is called galvanic cell. In electrolytic cell, what is electrolytic cell? In electrolytic cell, this is the device in which chemical energy occurs in presence of applied electric energy. Means in electrolytic cell, we are applying electricity, we are applying electricity into the cell, and because of that electricity, chemical reaction occurring in the cell. And in galvanic cell, here electrical energy is produced or generated because of chemical reaction which is occurring in the cell. Since electricity is producing, so galvanic cell is also called voltaic cell. Now this voltaic cell or galvanic cell can be divided in two types. One is called chemical cell, another is called concentration cell. Okay. So main important thing is that electrochemical cell can be divided into two types. Electrolytic cell, where electricity is used to break or to perform dissociation of electrolytes. That is called, means electricity is applied, and because of applied electricity, chemical change occurring in the cell. That is called means electrical energy converted to chemical energy. That is called electrolytic cell. In galvanic cell, chemical energy is converted to electrical energy. Next. Now this is the diagram of a galvanic cell. Say this is a galvanic cell of zinc rod immersed in a zinc sulfate solution. And here one copper rod immersed in a copper sulfate solution. This is called salt bridge, which is connecting this zinc sulfate and copper sulfate solution. This zinc rod and copper rod is externally connected by a wire. We put one voltmeter to check whether electricity is producing or not outside of the cell. Now, in this zinc, part, okay, on the left hand side, so this is total is called galvanic cell. Now, in this left hand side, what is the reaction will happen? In left hand side, zinc atom, which is present in the electrode, it's coming into solution but as a zinc 2 plus. So reaction is zinc 2 plus 2 electron. So zinc is a zero oxidation state. Now it's increasing the oxidation number. So it is an oxidation reaction. Since it is the oxidation reaction, so this electrode is called anode. Always remember that in galvanic cell, an anode is the electrode where oxidation occurs. In another, in right hand side, which is where copper sulfate solution is present, opposite reaction is happening. In this beaker or in this right side solution, copper sulfate solution, the copper sulfate is taking electron which is coming from zinc and is converted to copper, right? So it's taking electron and converted to copper. So copper is depositing. So copper 2 plus to copper, this transformation is occurring. So it is one type of reduction reaction. Since reduction reaction occurring in this right hand side electrode, this is called cathode. And these reactions are actually spontaneous reaction. Gives free energy change or this reaction is negative. The reaction in the left hand side electrode, the reaction in the right hand side electrode are called half reaction. When if we combine these two half reaction, we will get the net reaction. That is zinc plus copper 2 plus. It's going to form zinc 2 plus and copper. So what is happening? So when zinc is giving electron to zinc is releasing electron in this electrode and coming into solution zinc 2 plus. So this electrode will be reached in the negative charge. And copper 2 plus solution, copper 2 plus in solution is take electron from this electrode and convert it to copper. So this electrode will be deficient in number of electrons. So this electrode can be called as a plus. This electrode can be called as a minus. So this electrons will move from this side to this side. And in the salt bridge, it is moving from right hand side to left hand side. Salt bridge is actually bridging these two solution. In salt bridge, we are using generally potassium chloride. Since electrons is moving, so electricity is producing. So we are getting electricity from this spontaneous reaction. So chemical energy of this spontaneous reaction is converting to electrical energy in this galvanic cell. Next is the difference in electrical potential between anode and cathode of a galvanic cell. Say this is one solution, this is another solution, there is one electrode, there is another electrode. It's connected with a voltmeter. So we have to know what is cell voltage, what is electromotive force, EMF, and what is cell potential. So already I discussed that cathode will be positively charged, right? This is the cell reaction, okay. And E0 is called standard electrode potential. Standard electrode potential of the cell. This is combination of standard electrode potential of standard electrode oxidation potential and standard reduction potential. Means for this first reaction, zinc to zinc 2 plus, it has some reduction, it has some potential. And for the second reaction, copper 2 plus to copper, it has also some potential. So when the reaction is oxidation, it's called oxidation potential. When the reaction is reduction, it's called reduction potential. So if we combine the potential of oxidation reaction and potential of reduction reaction, we'll get the EMF of the cell. The 0 indicate the standard EMF. Okay. So what is oxidation potential? If the oxidation occurs at the electrode, the equilibrium, the potential of the electrode can be termed oxidation potential. For example, zinc electrode, the reaction can be depended by zinc 2 plus and plus 2 electrode. So the potential of this reaction is called oxidation potential. What is reduction potential? If the reduction occurs at the electrode, the equilibrium, the potential of the electrode is referred to as reduction potential. For zinc electrode, the reaction can be presented as the opposite reaction. Standard reduction potential, standard electrode potential means when we are calculating the potential in a standard state, means 1 atmosphere pressure and 25 degree or 298 Kelvin temperature. When we are applying this condition of standard state, then it will be called standard potential. How we can get the cell potential? If we add the oxidation potential and reduction potential, we'll get the cell potential. Now, what is Sol bridge? Sol bridge is an important component of an electrochemical cell. Without Sol bridge, and you cannot get the electricity. Sol bridge is usually an inverted U tube filled with the concentrated solution of inert electrolyte. Inert electrolyte is one of those are neither involved in any electrochemical change or do not react chemically with the electrolytes in two half cells. Generally, sodium, potassium chloride, potassium nitrate, ammonium nitrate are used along with agar-agar gel in the Sol bridge. The following are the function of the Sol bridge. First, it connects the solution of the two half cells and complete the cell circuit. Second, it prevents diffusion or mechanical flow of the solution from one half cell to another. And third, it prevents or minimizes liquid junction potential of the cell. So, what is the importance of Sol bridge? These are the three importance of Sol bridge. Next is the standard electrode potential, already discussed. Now, in our experiment, we need one reference electrode. Reference electrode, why? Because when we have to calculate the standard electrode potential of a particular reaction, for example, zinc to zinc 2 plus, we need some reference reaction. For that, we need some reference electrode. So standard hydrogen electrode, abbreviated as standard hydrogen SHE, is the redox electrode, which forms the basics of the thermodynamic scale of oxidation reduction potential. To form a basic for comparison with other electrode reaction, the hydrogen standard electrode potential is considered as 0. Okay, so hydrogen is considering as 0. Now now we have to calculate the electrode potential with comparison with hydrogen. If the potential is higher than hydrogen, we will say positive potential. If the potential lower than hydrogen, we will say negative potential. So if we measure the potential, if we measure the reduction potential of different reaction and calculate the potential with respect to standard hydrogen electrode, we can get one series. So standard reduction potential of a standard hydrogen electrode is this one, 0. Is 0. Now, if we measure the standard reduction potential of other reaction, okay, we can get some values. Now, if the values are in positive, okay, the values are negative, right? It can be positive or negative. So based on that, we can make one series. Based on these values of potential, we can make a series. This series is called electrochemical series. So if the potential is high, means this material, if the potential is high, means this material reduction potential positive. So these reactions are thermodynamically or feasible or spontaneous reaction. If the potential value is negative, means the reactions are thermodynamically non-spontaneous reaction. So this reaction non-spontaneous, but opposite reaction will be spontaneous. Because of that, if we take lithium metal, barium metal, calcium metal, keep and put in some H plus solution, they can produce hydrogen, because the opposite reaction, right, this reaction has a negative potential, so opposite reaction will be positive potential, so opposite reaction will be very uh, spontaneous. Since it will be opposite reaction will be spontaneous, so it has ability to generate hydrogen. So the reactions which is written here below this hydrogen, those reactions cannot evolve hydrogen. The reactions which are written above of this here, they can be used to get hydrogen from a cell solution. Okay. Next one, EMF. EMF full form is electromotive force. Okay. So electromotive, how we can calculate? Means what is the relation between electromotive force and gives free energy of a reaction? So relation is delta G is equal to minus NFE. N is the number of electron. Okay. Transfer in the redox reaction. E is the electrode potential and F is the Faraday. Okay. And we know another equation, that is delta G0 is equal to minus RT ln K, where K is the equilibrium constant, R is the universal gas constant, and T is the absolute temperature. So from these two relations, we can say that if we know the EMF of a cell, we can calculate the Gibbs free energy of a reaction, and then we can say whether the reaction is spontaneous or not. If the EMF value is negative, so delta G value will be positive, then reactions will be non-spontaneous. If E value or potential value is positive, then delta G value will be negative and the reactions will be spontaneous. And also we can, if we use standard state, we can calculate E0 value. From E0 value, we can calculate delta G0 value. Now, if we know delta G0 value, we can calculate equilibrium constant of a reaction. Next one, very important, Nernst equation. So Nernst equation, this Nernst equation is equal to E0 minus nRT by minus RT by NF ln Q. Q is called reaction quotient. Say if it is, let's say this is one reaction, that small a is the number of moles of A molecule reacting with B number of moles of B molecule and producing C number of mole of C molecule and D number of mole of D molecule. Then reaction quotients will be concentration of C to the power C into concentration of D to the power D divided by concentration of reactant, like concentration of A to the power A, concentration of B to the power B. Now, Nernst equation is equal to E0 minus RT by NF ln Q. That is the Nernst equation. Now, if we apply some condition like 25 degrees Celsius, then R value, you can note the R value, T will be 298 Kelvin. If N value is 1, F value we know 96,500, right? So if we put all the value, we can get the Nernst equation equal to 0 minus 0.059 by N ln Q. So next one thing, Nernst equation enables to calculate E as a function of reactant and product concentration in a redox reaction. For example, in a Daniell cell, which is galvanic cell, zinc plus copper 2 plus zinc 2 plus copper. Now in this reaction, we can easily calculate E value. We know E0 value for this reaction is 1.10 volt. Okay. And if the concentration of copper 2 plus and zinc 2 plus is 1 molar, right, this Ln value will be 1, so it will be 0, so E value will be equal to E0. Next thing is calculation of standard reduction potential for zinc 2 plus zinc system and copper 2 plus copper system. It's already given. So they are telling calculate the potential of the Daniell cell. If the standard reduction potential is given, so we can easily calculate E cell. That is the, if we have to add it, okay, E of oxidation plus E of reduction. If we add it, we can easily get the E cell value. Okay, that is 1.1 volt. Last one is the application of the Nernst equation. So a Nernst equation can be applied in different field. We can apply the potential of an electrode and EMF of a cell can be calculated at any temperature and the concentration. Knowing the potential of an electrode, the concentration of a reactant can be calculated. The concentration of a solution in galvanic cell can be determined. The pH of a solution can be calculated by measuring EMF. There are many more applications of a Nernst equation. So what we have understood from this topic, we have understood that in electrochemistry, we are discussing the oxidation reduction reaction in solution. We understood what is anode, what is cathode. We understood what is Nernst equation. We understood the relation between Gibbs free energy and EMF of a cell. Okay, I hope this video will help you in your BTech chemistry class. Thank you all for listening.